Good morning. Welcome to your penultimate lesson of the year. Yes, it is your second to last math lesson. We'll do one today. We're going to finish this one up on Friday. We're going to do something a little special on Monday. And then maybe a little something on Wednesday, and you guys are done. So I can't believe it. You guys are almost freshmen. That's awesome. So today we're going to talk about some irrational numbers. Now, the first meme I had up the other day says, "Don't you guys think you should stop fighting? You're both being irrational." So today we're going to learn about what that irrational actually means. So Woody, let me introduce you to irrational numbers. These numbers are irrational because there is no pattern and no end. Well, there's your nice little introduction. Now let's look at it. Okay. So what is an irrational number? Well, it's not rational. Didn't really help, did it? Okay, let's really try what it is. So what does that all mean, Basil? Well, if you guys remember from last class, we said a rational number is any number that you can write as a fraction, as an integer over an integer. Okay. And B, obviously, your denominator cannot be 0. Well, an irrational number cannot be written as a fraction of an integer over an integer. All right, so let's look at what some irrational numbers are. So an irrational number is the square root of any number that's not a perfect square. So 4 is a perfect square, so its square root, rational. Square root of 5, not rational, irrational. Square root of 10, irrational. Square root of 16 is 4, so that is rational. It can be the cube of any non-perfect cube. So if you remember, 8 was 2 cubed, so that's rational. Cube root of 9, not rational. Cube root of 10, not rational. Then other things like constants that you are starting to get into. So the first one is pi. So pi is irrational. So is e. It's the natural exponential. You get to that when you get to probably algebra 2. So it's basically any number that can be written as a decimal, but that decimal does not repeat and it does not terminate. So it goes on forever and ever and ever, and there is no pattern of repeating at all. So that leads us to some of the numbers. I think I went over this part with you earlier in the year. So when you first start learning numbers, you learn natural numbers, which are just 1, 2, and 3. And then they throw in 0, which is a whole number. So all the whole numbers include the natural numbers. Then you throw in integers. Now, integers are whole numbers that are both positive and negative. Then you throw in rational numbers, which are fractions, which you can write as numerator, denominator, as an integer, the negatives, and then repeating decimals or terminating decimals. That leads us to, so there's 2 kinds of real numbers. Yes, the word real. Does that mean that there are unreal numbers or imaginary numbers? Yes, algebra 2. You'll get there. So rational numbers is one branch of real numbers. The other branch is irrational. So these are what irrational numbers look like. So now what we want to do is look at them and say, okay, are they rational or irrational? So if they're rational, they are square root of a perfect square, terminating decimal, or fraction, maybe another fraction. Okay. Radical 12. That is irrational, correct. Okay, because it is not a perfect square. 0.2, negative 0.25 repeating. Rational, correct, because we have a repeating decimal here. Because it repeats, it is therefore rational. Negative square root of 9 is rational, correct, because the square root of 9 is a perfect, or 9 is a perfect square, so the square root of 9 is 3, which is a rational number. Cube root of 15. Yeah, there ain't no cube of 15. That is irrational. Well, there's cube root of 15. Yep, irrational. There is no number that you can multiply by itself 3 times and get 15 and have it be a rational number. Impossible. And finally, pi, we had said, is irrational. So now what we're going to do is we're going to try to find the value of an irrational number. And to do that, what we're going to do is we're going to do 2 parts. We're going to find the integer of it, to the nearest integer and to the nearest tenth. And there's a way to do it. It's really not that complicated. You did this years ago with fractions, and you didn't necessarily understand what fractions were, but you compared them to benchmark fractions. So for example, let's say it was 11/23. All right, in the beginning, you're like, what in the world's 11/23? It doesn't make any sense. And then you benchmarked it to, oh, it's about a half. All right, it makes sense. So that's what we're going to do with the same thing here. So the square root of 71 to nearest integer. What we want to do is come up with what are our perfect squares. So our perfect squares are, well, 7 squared is 49, 8 squared is 64, 9 squared is 81. Okay, so 71 falls in between 8 and 9. Okay, because if 8 squared is 64 and 9 squared is 81, it's going to fall between 8 and 9. Now, here's the way you also look at it. If you look at the perfect squares, if you cut halfway in between the perfect squares, that's going to be halfway between the numbers. So 49 is 64 is a difference of 15, so half of that is 7.5. 7.5 more than this, so about 56.5 would be 7.5. Okay, so if it's less than 56.5, it'd be closer to 7. More than 56.5, it's closer to 8. Well, what's in between? So 71 is between 64 and 81. Well, that's about 17. Half of that is 8. So 8 more than that's about 72. So 72 is about 8.5-ish. So this is less than 72. Okay, so that would mean it'd be closer to 8. That's all you have to do to solve that part. Well, now we're going to get to the nearest tenth. That's a little bit more complicated. So now what we're going to do is we're going to try to figure out radical 71 to the nearest tenth. So again, what we're going to do is, instead of doing whole number squareds, we're just going to use decimal squareds. Not that complicated. So 8.3, you're going to use your calculator to do it. So 8.3 squared is 68.89. 8.4 squared is 70.56. 8.5 squared is 72.25. Okay. So which one is it closer to? Well, 71 is clearly closer to this one than that one. So radical 71 is about 8.4. Now some of you are like, wait a minute, Miss Prod, I can just use a calculator. You're right. You could just use a calculator. This is, if you don't have a calculator, how can you estimate its value relatively quickly? Now let's look at this one, square root of 8. Okay, so 2 squared is 4. 3 squared is 9. So the square root of 8 is really close to 9. So the square root of 8 is about 3. That's it. Not really that bad. So now let's get that to the nearest tenth. Okay. Okay, so it's going to be between most likely 2.9 and 3. So we're just going to come up here, do 2.9 squared. That comes out to be 8. Oh, it's less than that. So 2.9 is 8.41. So now let's do 2.8 squared. That comes out to be 7.84. So 2.9 squared was 8.41. And then 2.8 was 7 point, sorry, I forgot it for a second, 84. So 8 is closest to 7.84. So to the nearest tenth, it's about 2.8. Let's do it for negative 13. All right, so 3 squared is 9. 4 squared is 16. So 13 is 3 away from 16 and 4 away from 9. So that's about 4. Okay, and because there's a negative out in front, we put a negative sign, so negative 4. Now let's take a peek at what it will be to the nearest tenth. Well, let's think about it for a second. This is pretty close to the middle, so it's going to be somewhere around 3.5. So that's where we're going to start. So 3.5 squared is 12.25. 12.25. So it's bigger than that. So let's do 3.6 squared. 3.6 squared is 12.96. Well, I don't even need to go any further than that. 12.96 is really close to 13. That's just what it's going to be. Okay. So this is about 3.6, and because there's a negative when you have a negative, so negative 3.6. Oh my goodness, there's a cube. Yep, you're right, there's a cube. So let's go ahead and come up with our perfect cubes. So we know that 5 cubed is 125. Well, that's nowhere near where we need to go. Let's jump up to 6 cubed. Do I know what 6 cubed is off the top of my head? No. So we're going to plug it in. Oh, there it is, 216. So let's go to 7 cubed. 3, 4, 3. So radical cube root of 310 is in between 6 and 7. It's clearly closer to 7 than it is to 6, because if you notice, right, it's 100, almost 100 away from 6, and it's only 33 away from 7. So this is about 7. Now, can we get that to the nearest tenth? Of course we can. So so halfway, well, actually, it's the halfway thing doesn't work here. So let's just take a gander. Let's try 6.7 squared, because it is closer to 7 than 6, and this is just going to be a good starting point. Try with 6.7 cubed, and let's see what we get. That's 301-ish. All right, what we at 310. All right, so 6.8 cubed is 6.8 cubed is 314. Well, that's close enough for me. Okay, so it's about 6.8. Okay, so that is what you guys are working on today. Please reach out to me if you have any questions. Good luck. Bye.